All right, so we're back for the second video. Hopefully you took a little break. Maybe it's the next day. Hopefully you took a little break and studied those functional groups and you're now familiar with them. So now we're going to talk about naming those functional groups and naming organic compounds. Right, so first I want to just talk about properties, and this is going to be very brief. I left it in here though because there are a few hit and miss pieces on the exam to do with properties of different functional groups. So the properties of an alkane, right? And these are the single bonded carbon hydrocarbons. All right. So there's no heteroatoms, meaning there's only carbon and hydrogen. Heteroatoms are anything that are not carbon and hydrogen, and they're nonpolar molecules. So this makes them insoluble in water and makes them hydrophobic, insoluble in water, basically, another way of saying that. In general, alkanes have low melting points, lower than any other compound. And if we increase the number of carbons within just alkanes, we can increase the boiling point. So here is definitely where I'm going to stress that this is on your midterm. So although alkanes in general have low boiling points, if I were to compare boiling points of several different lengths of carbon chains here, we would increase boiling point as we increase the chain length. And this is the same for melting point. All right. So more carbons equals harder to melt. Okay. And so this is just a picture depicting that same thing that I just drew here, only it's putting numbers on it. I don't know how accurate this is, but a 3-carbon chain has a boiling point of negative 42 degrees Celsius. When we add another carbon, it becomes 0. We add furthermore, add another carbon, becomes 36, and another carbon, 69. Okay. So this question is your question 6. I did remember explicitly updating this one. So this asks you, again, it's matching to arrange them lowest, highest, intermediate. And so first I'm going to count the carbons. And so in this first one, I have 1, 2, 3, 4, 5, 6. So we have 6 carbons, 1, 2, 3, 4, 5, 6, 7 carbons. 2, 3, 4, 4, 5. Sorry, my iPad just did something funky here. 4, 5. All right, so 5 carbons. So 5 carbon is going to have the lowest boiling point. The 6 carbon is going to have the intermediate, and the 7 is going to have the highest boiling point because we increase boiling point as we increase the number of carbons in the chain. All right, so alkenes and alkynes have similar properties to alkanes, where they are nonpolar. As we increase the amount of carbons, we increase the boiling point. The only thing here is that alkenes have a melting point and boiling point that is slightly higher than the same number of atoms in an alkane. So it becomes a little bit harder to melt them when we have that double bond, basically. All right. And so in the first video, I said that the 4 functional groups that we are talking about this lecture is alkanes, alkenes, alkynes, and alcohols. So alcohols, right, are when we have an OH group. And so these act a little bit differently. They are soluble in water with some exceptions because, it's chemistry. We always have exceptions. The general rule is that it is soluble with one hydroxyl. Hydroxyl group is the same as this OH per 3 to 4 carbon atoms. This hydroxyl group makes it able to hydrogen bond, and it has a slightly higher, not slightly, a greater boiling point than alkenes, alkanes, and alkynes. And so I believe my next slide depicts that. Yeah. So here we have that same picture that I showed earlier. Now we have alcohols with the same number of carbons. So here we had 3 carbons, here we had 4 carbons. But we can see that as soon as we add this OH group, we dramatically increase our boiling point. Okay, so alcohols are more soluble and have higher boiling points. So I was going to take this slide out and I forgot to. I'm sure I forgot. Yep, take that, pretend that one's not there. Okay. So naming. So this is going to be the heavy hitting part of organic, is naming all these different molecules, and its naming is based off of the functional group present. And so that's why I really stress that you learn the functional groups. But just a little bit of background. Let's start about how we count carbons. So some of the first steps, well, the first step in all of these naming organic molecules is going to be to figure out the length of the longest chain. So sometimes this is not as intuitive as we might think. So for this first molecule here, it is intuitive. We have 1 carbon, 2 carbon, 3, 4, 5, 6. But as we start to build branches, it starts to become a little bit more difficult. And so basically, we want to continue the chain as long as we can. So I could count 1, 2, 3, but I've stopped the chain at 3 carbons. And so it would be more beneficial for me to call this 3, 4, 5. Same with this guy. I could count 1, 2, 3, 4, but it would be more beneficial for me to say 4 and then 5. So the backbone chain sometimes doesn't correlate to how many carbons are actually in the structure. Okay, so with here, it was a 6 carbon total, and the backbone is also 6 carbons. We're naming off of the backbone chain, but here there is also 6 carbons present, but our longest chain is 5 carbons, and that's going to dictate the naming. Same with this one. There's 6 carbons total, but the longest carbon chain length is what dictates naming. Just for the sake of completing this slide here, this one is a little funky. I could call this one 1, or I could call this one 1, but no matter what, next one is going to be 2, 3. And again, I could call this 4, or I could call this one 4. It doesn't matter. My longest chain will be 4. All right, here I could call any of these 1, 1. Doesn't matter because the next move I make is 2, 3, 4. All right, so counting carbons is important. All right, so you're going to see this slide over and over. So naming organic molecules has this, it's called the IUPAC naming system, in which there's kind of this general outline here. So we have the prefix, the parent, and then the suffix. So the suffix is going to be based off of your functional group. The parent is the number of carbons in that longest chain. And then your prefix is anything coming off of that chain. So these are branches off the chain. So, okay. So when we look at a molecule right now, this example molecule we're looking at is an alkane. And so its suffix is always going to be ane. So I'm going to count the number of carbons. 1, 2, 3, 4, 5, 6. All right, so we don't just say 6-hane. If you noticed in the other slide that there's a parent name associated with the number of number of carbons in the longest chain. And so for 6, it's hex. And so this molecule is hexane. There's no branches coming off, but if there were, I would take care of that in front. And so naming organic molecules, you're almost working backwards. You're identifying the functional group present, you're identifying your longest chain, and then you're taking care of anything coming off of it. Okay. So alkanes get a little tricky. And so we're going to see this slide again here. So let's erase this. All right, so we already know what's the longest chain, but it depends on where we put our 1. So with this guy that we just looked at, hexane, it didn't really matter if we went right to left or left to right because there's no branches coming off of it. But in other molecules, such as things with branches like this guy, it does matter where we start with 1. So in the previously, I was just numbering left to right because that's what's logical. But with organic chemistry, if there's a branch coming off of an alkane, I want to make him the lowest number possible. Excuse me. So I could number right to left, or I could number, I'm sorry, that was left to right, or I could number the opposite way. So if I were to number left to right, my branch is coming off of carbon 2, which is what I want. That's the lowest carbon it could possibly come off of. If I were to number it right to left, it'd be coming off of carbon 4. So with alkanes and branches, I want them to come off of the lowest. So this is the correct numbering scheme. So we already said that this guy is hexane. So what the heck is this? It's an alkane, so it has an ane ending. It has 5 carbons in its longest chain. And so if you were to go to the back a slide, or maybe you have them printed in front of you, but 5 is pent. So this is pentane. Now, if I just were to say to my audience, pentane, you would just draw what I have circled here, and I'm going back over it. You wouldn't know about the branch. So we need to tell the audience about the branch. And so how we do this, sorry, I feel like I'm going to sneeze again. All right, so how we do this is we tell what carbon it's coming off of, and then what the branch looks like, basically. And so this is also goes off of your parent names from the previous slide, okay? So let me just write this back over here. So 1 is meth, 2 is eth, 3 is prop, 4 is but, 5 is pent, 6 is hex, 7 hepta. I'll just stop there for now. So this is coming off of carbon 2. So I know that it's 2. And then it's a 1 carbon branch. And so I'm going to use the term meth. Now, we don't just say 2-meth pentane. When it's a branch, we add these endings to it. So these YL endings. So it's methyl, ethyl, propyl, right? So this is a 2-methyl pentane. Okay. So in organic naming, I always separate a word from a number with a hyphen, but I don't need to separate these two words. In fact, they like it when it's all methylpentane. Okay. I should have said this in the last slide, but so with the, if you go back to the last slide, you know what, I'll just go back. So, 5 pent, hex, hepta, octa, non, deca, those are somewhat familiar, right? We talked about those in our other what was it? Making molecular compounds. But meth being for 1, eth being for 2, prop being for 3, bute being for 4, those might be a little unfamiliar. And how my organic teacher had us memorize these was the saying, monkeys eat peanut butter. And so monkey being for meth, eat being for eth, p being for prop, b for being for but. So cute little saying. All right, so going back to this slide, I am going to erase some of this so we can work on this next guy. Come on. What? Okay. Well, that's bizarre. It doesn't want to erase. Okay, well, I apologize. You know what? Actually, you guys can pause and go back. So I'm going to just erase this entire slide. There we go. Okay, so we already talked about that this is a couple slides ago, that this is a 5-carbon chain. This is a fun one where I could number it left to right, or I can number it right to left. And they actually both times ends up on 3, the branch. So it doesn't really matter. But to name this, I'm working backwards. So I'm using the suffix ane because it's an alkane. It has all single bonds. It's a 5-carbon chain, so it's pentane. And I have a 1-carbon branch coming off of carbon 3. So I'm going to say, hey, this is coming off of carbon 3, and it's a methyl group because it's 1 carbon. All right. And so this guy, okay. We said it was a 4-carbon. I unfortunately might have to make these in 2 videos because I'm getting a low battery message, but okay. So I could also name or number this right to left or left to right, and I would still have these 1-carbon structures coming off of 2 and 3. Even the same thing, if I were to number this as 1 and this is 4, I would have a 1-carbon structure coming off of 2 and a 1-carbon structure coming off of 3. So that's a fun little catch that I think is fun with organic chemistry. Okay, so let's erase those. Come on. Okay. All right, so we're going to use the ending ane because this is an alkane. We're still in our alkane examples. Now this time we have 4 carbons, so it's bute or but it's pronounced butane. And then now we have carbons coming off of 2, and 3. So now we're in a fun little predicament here. So now we have to tell our audience, hey, I have something coming off of 2, and I have something coming off of carbon 3. Now, it makes the most sense to me to just write methyl next because, come on, so a 1 carbon structure coming off of 2 and 3, they're both methyls. But for some reason, the IUPAC naming said, you have to tell us how many methyls there are total, which makes no sense to me. But then we'll write it as dimethyl butane. So this is saying, hey, there's 2 methyls coming off of carbon's branches, and one is on carbon 2 and one is off of carbon 3. Okay, so again, hyphens separate numbers and words, but commas separate numbers and numbers. All right, so here's another fun one. So I can number left to right or right to left. This time it does matter. I'm gonna want to use left to right because that puts my branches here at the lowest carbon. It puts it at carbon 2 rather than carbon 3. So again, we're still in our alkane example. So it's going to have the ending ane. It's a 4 carbon backbone chain. So it's going to have the parent name of but or bute. So this is another butane. Now, we have, this is 2 branches coming off of the same carbon of the same length. Okay, so I know it might seem logical, hey, there's 2 carbon branches, isn't that when I use the ethyl convention? But no, we're still in methyls. So this time we're going to tell the audience 2,2-dimethyl. So we're saying there's 2 methyl branches and they're both coming off of carbon 2. What an ethyl off of carbon 2 would look like. So here's our backbone. It would be that this carbon chain is then continuous with the second carbon. So you have your carbon chain of 1, 2. Okay. All right, I think I'm gonna, no, we'll do this one. All right, so looking at your OWL question 4, we're asked to name this alkane. And so first I'm gonna go through and number the parent chain. I can number from left to right or right to left. Since it has a branch coming off of it, I want to position that branch at the lowest possible number that it could have. And in that case, we're looking at left to right. So we know this is an alkane, 1, because it's stated in the problem, 2, because it has all single bonds. So we know that the suffix is going to be ane. It's a 6 carbon structure. So it's going to take on the ending, or I'm sorry, the prefix hex. So hexane. And it has a branch. So this branch is coming off of carbon 3. And it's a 1 carbon branch, so it's a methyl. So when we type this in, my spacing was a little off here because I was working backwards. So it'd be 3-methyl, no space, directly into hexane. All right. So now we're going to talk about cycloalkanes. So we kind of preluded that alkanes can form circles and or not circles, but circular structures, whether it's 3 carbon, 4 carbon, 5 carbon. We talked about 6 carbon being the most common. And so how do we tell our audience that, hey, this is 3 carbons or this is 6 carbons, but they're in a circular formation, they're all connected? So we still use the same naming rules, but instead, well, in addition to everything else, we say cyclohexane or cyclopropane, right? So here is a 3 carbon structure, which makes it propane because it's all single bonds, but because they're circular, cyclopropane. Same thing here, 6 carbon structure, that's all single bond, so hexane, but because they're circular and all connected, cyclohexane. So your OWL question 5 deals with some practice, so let's go ahead and practice. All right, so let's count carbons. We're going to count carbons with all the carbons that are attached to each other, or basically in the circle or in the ring. I should be using the word ring instead of circle. So it ends in ane because they're all single bonds. It's 5 carbons, so the prefix will be pent. And because it's a ring, cyclopentane, all one word, no spaces. Here, they liked, even though this question is about naming rings, they decided to throw in a linear structure. So this is an alkane, so it takes on the ending ane, all single bonds. And it is 8, so it takes on the prefix oct. So octane, no branches coming off of it, so nothing else needed. Here we have a 4 carbon ring. It's all single bonds, so we're going to end in ane. 4 is bute, so butane, and then we need to throw cyclo in front of it because it's a ring. All right. So what the heck do we do if it has branches? So your ring is always your parent chain of carbons. We're always numbering the ring. And you basically can start at any point, but you want to put yourself in a position in which the branches are at the lowest. So here we have 2 potential branches. So what the heck do we do then? So you want to list your branches in alphabetical order. Additionally, we're going to throw these branches on the 1, 2 position. We could even say 1, 2 here, and it actually would be the same as long as they're in the 1, 2 position, because if I were to flip this, it would still be the same structure if we were to like hold it in 3D. Okay. So wherever we put 1, though, we want to make sure that 2 is the next guy, right? We don't want to go 1, 2, 3, 4, 5, and put this fluorine in the 6th position. We want to put them both in the lowest position. And so that would be by doing clockwise 1, 2, 3, 4, 5, 6. Okay. All right, so all the other naming conventions still apply. So this is a all single bond, so it's going to take on the ending ane. It is a 6 carbon parent chain, so it's going to be hexane. We're going to tell our audience that it's a ring by saying cyclohexane. Didn't mean for there to be a space there, but again, writing backwards. All right, so now we got to tell our audience about the branches. So this is, I think, the first time we've dealt with 2 branches. And so this listing the branches in order applies to linear branches as well, multiple branches on linear structures. So we have one ethyl, right? Because this is a 2-carbon structure coming off of the first carbon. And here's actually the first time we've also dealt with heteroatoms. So fluorine, bromine, chlorine, these are all popular atoms to come off of organic structures. And so they have these cute little prefixes that are very similar to their name. So fluorine is fluoro, bromine is bromo, chlorine is chloro. I can't think of any other popular ones at the moment. So this should cover all of our examples. So this 2 is 2-fluoro. So I'm going to list them in alphabetical order. So E comes before F. To me, it seems logical that we would just list them in whatever numerical order, lowest to highest, but no, we list them in alphabetical order. This also just happens to correspond with how we numbered them. So we have 1 ethyl. Now, between numbers and words, I use hyphens. Fluoro. And then it would jump right into cyclohexane. I didn't mean for there to be such a gap. So let me rewrite this here. So 1-ethyl, 2-fluoro, cyclohexane. All right, let's throw another example in there. So again, a cyclohexane, but let's do a methyl branch and then a bromide branch. All right, so I'm going to number it 1, 2, 3, 4, 5, 6. So it doesn't really number, it doesn't really matter if I did started 1, 2, as long as I put these 2 in the 1, 2 position. All right. So again, I have a cyclohexane, so that will be our ending. So now I'm dealing with a 1-bromo and a 2-methyl. So the one that gets listed first is the lowest one alphabetically, which again just happens to correspond with how we numbered them. So 1-bromo hyphen 2-methyl cyclohexane. Right. All right. So your owl question 5 is naming cycloalkanes. So here we have a 4 carbon ring, right? That's all single bonds. So it's going to take on the ending ane. It's 4 carbons, so it's going to be butane. We're going to tell the audience it's a ring by saying cyclo. And now we have to tell them about this branch. I'm going to make sure the branch, if there's only one branch coming off, I might as well just put him in the first position. This is a 2-carbon branch. So this is an ethyl branch. So 1-ethyl cyclobutane. Whew, mouthful. All right. So that brings us to alkenes, right? Lots and lots of alkane stuff. So it starts to get a little bit easier from here, now that we know the general structure. But everything we learned about the numbering and putting the branch at the lowest only applies to alkanes. Any other functional group from here, we want to put the functional group at the lowest carbon. So here I have an alkene. It's going to take on the same kind of structure where you have prefixes where you deal with branches. You have your parent, where you talk about the number of carbons, and you talk about your suffix, which identifies what functional group. So even if there's just one double bond present, it becomes an alkene, and it's going to take on the suffix now "ene" instead of "ane." So I can number this left to right or right to left. And now, because we're dealing with functional groups, we care about putting the functional group we're naming from at the lowest possible carbon. So carbon 2,3 is more desirable than 5,4 or 4,5. All right, so we're going to number left to right. Okay, so this has a double bond present, so it's going to take on the ending "ene." It's a 6-carbon structure, so we're going to use the prefix hex. All right, but we can't necessarily stop there. We have to tell the audience where that double bond is. And so we're going to do that by putting a number of the carbon right before the parent name. All right, so it spans 2 to 3, but we need to only tell the audience the lowest number, and it's implied, okay, if you're telling me 2, then it spans from 2 to 3. If you tell me 3, then it spans from 3 to 4, right? So we tell them the lowest number, and so in this case, it's 2. We still use the hyphen, so 2-hexene. All right. So let's practice that a couple times here with some OWL questions. All right, so here we have an alkene, right? And we know that because there's a double bond present. So we're using the suffix "ene." All right, so now we need to number the carbon chain. So I can number right to left or left to right. In this case, this is one of those that it doesn't matter. Both of them span from the 4 to 5 position, okay? It's symmetrical. So it doesn't really matter, but I am going to cross off the second, just so I don't confuse myself. All right, so "ene," because it has a double bond present. "Oct," because this is an 8-carbon parent chain structure. And then I'm going to tell my audience, hey, our double bond spans from 4 to 5, but I'm only going to tell my audience by saying 4 because they are going to know that I'm giving them the lowest number. So it spans from 4 to 5. Okay. So here's the tricky thing. With 4-carbon alkenes, they can take on 2 positions. One where I've kind of have been depicting in the last few slides here, where it's kind of like a Z, a sideways Z. But it technically could also be kind of like half of a hexane ring here. So, oh, I meant to change these to F. So if I were to go through right now and name these, so all right, so if I were to go through and name these right now, I'd want to, I said earlier they're 3-carbon, 4-carbon, I'm sorry, these are 3-carbon. I'd want to decide my naming conventions. I could go left to right, or I could go right to left. Now, before this, we cared about the branches. Now, because there's a functional group present other than alkane or all single bonds, I care about that. So I'm going to be naming right to left here because that puts my double bond at the 1 position rather than naming right to left, which puts it at the 2-3 position. Okay. Now, if I was to do the same over here, I would number left to right because I put my alkene bond at the 1 to 2 position. So this is a propene. All right, so ene because it has a double bond present, prop because it's a 3-carbon parent chain, 1 because that is where it's coming off of. And now we need to address the branch, which we haven't had an alkene with a branch yet. So this is 1 coming off the first carbon, and it's a fluoro or a fluorine atom. So I say 1 fluoro hyphen 1 propene. Now, if I was to name this guy on the right, you could go through it, but it's going to be named the exact same thing. So how do I tell my audience, hey, 1 is got the carbons facing basically in a Z formation where the other is in more of a boat kind of formation. So we use the prefixes then before everything else, and we say cis or trans, okay? So cis is when they are on the same side, right? So here, the atom and then the other carbon atom were on the same side, and trans, they're on opposite sides. Now, remember, there's implied hydrogens. Ooh, let me change color actually. There's implied hydrogens here. There would only be 1 actually. And here. So the hydrogens, you could also, if you wanted to determine cis and trans from the hydrogens, you could also determine it that way, right? Because here the hydrogens are on the opposite side, and here the hydrogens are on the same side. So I think on your test, it has the hydrogens explicitly written out. And so that's why I wanted to show you, hey, there's still hydrogens there. Don't let that stop you from what you're trying to solve. All right, so going back to the naming. So now I need to tell my audience, hey, this one's trans. They're on opposite sides, and this one is cis. They are on the same side. So I do that by just adding the prefix to the entire name. He comes before the branches. Okay. All right. So that's alkenes. All right. Now we'll do alkanes. So again, similar setup, but now we use these naming conventions anytime a triple bond is present, because that is what an alkane is. So here's my triple bond. And I'm going to use the suffix ane now. All other naming conventions are the same. So again, I can number left to right or right to left. And what I care about is putting that alkane bond in its lowest position, which is the left to right, right? So now my suffix is ane because there is a triple bond present. Hex because it's a 6-carbon structure. And then I need to tell my audience, hey, this bond spans from 2 to 3, but if I just tell you 2, you know that it's implied that it goes from 2 to 3, it goes up from there. We just give them the lowest carbon number, okay? So, some practice. Question 8 asks you to name alkanes. So very similar to the practice we had for alkenes, we want to number our carbon and it's actually symmetrical. So if I number left to right or right to left, the triple bond ends up at the 4-5 position. So because there is a triple bond present, I'm going to use the suffix "ane." There's 8 carbons in the parent structure, so oct. And that triple bond is spanning from 4 to 5, but I only need to tell my audience 4. It's implied that it goes low to high. Okay, so this is 4-octane. All right. So our last functional group of this lecture, again, takes on the same naming conventions. I don't know why I didn't use the same slide, but takes on the same naming conventions. But now the suffix for alcohols, and I have a typo here, is enol, right? So instead of saying "een," "ane," "ein," if there's alcohol present, right? And hopefully we've started to nail down our functional groups. An alcohol group is an OH group. All right. So with this one, I want my longest chain to be as long as possible, but I want to make sure that the alcohol group is there. And he's the star of the show. So I want to put him at the lowest carbon. So for the structure here on the left, I can number left to right, or I can number right to left. Well, my alcohol group, he's the star of the show. And so I want to name him right to left. All right. I could have put in 3 here. This is basically, if I rewrite it, I could put 3 here or 3 here. It doesn't actually matter. The name will be the exact same. All right, so we've decided how we're going to number this. I'm going to erase this. All right. So now we're going to take on all the other same naming rules, but my ending is enol. Okay. So all right, so enol. This is a 3-carbon, so it takes on the parent name prop. So this is propanol so far. So if my alcohol falls on any other carbon, like 2, 3, 4, 5, I need to tell the audience which carbon it's coming off of. Because if it comes off of carbon 1, then I can just leave it off. Chemistry loves to leave off a 1 and imply a 1 if 1 is present. So I can just leave it as propanol, and it's assumed because we number with alcohol being the star of the show that that's coming off the 1 carbon. All right. So then basically I just have to tell my audience about the branch. So on the 2nd carbon, there is a 1-carbon branch, which is methyl. So this structure on the left is 2-methylpropanol. All right. So what about alcohols coming off of rings? All right. So again, the alcohol is the star of the show. I'm going to put him at my 1 carbon. I can then go clockwise or I can go counterclockwise. If there was no other branches present, wouldn't matter which way I go. But because there's then another branch present, I want to go counterclockwise to put him then at the lowest possible carbon that he could be. So 3, 4, 5. All right. So now ends in enol, because the OH group is present. He takes precedent anytime he's present. It is a 5-carbon ring, so it has the parent of pent, but it's a ring, so we have to tell the audience cyclo. We've taken care of everything. I could tell my audience 1. Hey, this is on the alcohol groups on the 1 carbon. But because it's on the one carbon, then we're good. Everything's fine and dandy. I don't need to tell my audience that it's coming off of one. It's implied. If I don't say another number, then it must be coming off of one. But we do need to tell the audience, hey, I have a one carbon structure, so a methyl coming off of carbon 2. I want to give an example of when we do need to specify where the alcohol group is coming off of. So here's a good example here. So I can number right to left or left to right. And again, I want to make the alcohol the star of the show. But whatever I do, he's still going to be on alcohol 2. There's no way I can put him on the first carbon, because then I would be breaking all the like linear naming rules there. So this is still propanol, but now I need to be more specific and say, hey, the alcohol group is coming off of carbon 2. It's no longer coming off of carbon 1. So I'm going to explicitly tell you it's coming off of carbon 2. So this is 2-propanol. All right. So your AL question 9 deals with naming alcohols. This guy is a toughie, but my parent chain is here. I have an alcohol group coming off. So he's the star of the show. He's going to be what suffix I use. I have a 5 carbon. Yes, and I could number it left to right or right to left, and the alcohol group's still going to come off of carbon 3. We also have a 2-carbon branch coming off of carbon 3, so we'll have to address that. All right, so we're going to use the ending -anol because an alcohol group is present. We're going to use the parent prefix as pent because the parent carbon chain is 5 carbons. Because the alcohol group does not fall on carbon 1, I'm going to need to tell my audience, hey, that alcohol group is on carbon 3. And I need to address this 2-carbon chain, just happens to also come off of carbon 3. So it's a 2-carbon chain, so it's an ethyl group. So 3-ethyl - 3-pentanol. All right, one last thing dealing with naming and alcohols. So sometimes we can have an alcohol coming off of each end. This is a very unique example, but of course they wanted to put this on your exam. Okay, so I could number left to right, and remember I'm only numbering the carbons. This represents a bond, but this is not a carbon atom, okay? So I'm only numbering the carbons. I can number right to left or left to right. Here, it's always going to be 4, and I'm always going to have an alcohol group coming off of the 1,4 position, no matter what I do. So what the heck do I do when there happens to be 2 alcohol groups? It would make sense to just call this butanol and then say 1,4, but no, they want to be difficult. So if there's 2, the ending changes slightly to diol instead of anol. Anol. So this is a 4-carbon parent structure. I might have to check my spelling on that one. Okay, yes. So it's also spelled weird. Okay, let me rewrite this. So but Diol. Okay. You will not have to worry about the spelling per se because it's a multiple choice test. So, and they don't test you on the spelling. They're mostly testing you on the number of carbons and knowing what number of carbons they come off of. So don't worry about that part. All right. So we've told our audience, hey, there's 2 alcohol groups. And now we need to tell them, hey, they're coming off of carbon 1 and carbon 4. All right. That concludes our video 2.